Hello everyone! Today I'm going to explain some important concepts in kinematics and projectile motion and free fall. We will break it down step by step using simple language to help you understand the equations and how they work. Let's start with the kinematic equations. These are used to describe motion when an object is moving with constant acceleration. Here are the key equations. Number 1. Displacement. This equals VI multiplied by T plus 1/2 multiplied by A multiplied by T. This equation tells us how far an object moves given its initial velocity VI times T and acceleration A. Number 2. Final velocity. V squared F is equals to V squared I plus 2 multiplied to A multiplied to D. This one gives the final speed of an object after it have traveled a certain distance, starting from an initial velocity. Number 3. Final velocity. Vf is equals to Vi plus A multiplied to T. These equations show how the velocity changes over time due to acceleration. Number 4. Displacement. D is equals to Vi plus Vf over 2 multiplied to T. It tells us the displacement when we know the average velocity and the time. Now, let me give you an example. A ball is thrown vertically upward with an initial velocity of 20 meters per second. Calculate how high the ball will rise before it starts to fall back down. Gravity is g 9.8 meters per second. In here, v is the final velocity, 0 meters per second at the highest point. U is the initial velocity, 20 meters per second. A is the acceleration, negative 9.8 meters per second since it's acting downwards. S is the displacement, which is the height. Now, let's solve this. 0 is equals to 20 squared plus 2, negative 9.8 seconds. And this simplifies to 0 is equals to 400 minus 19.65. And 19.65 is equals to 400. And S is equals to 400 over 19.6, which is resulting to 20.41 meters. Thus, the ball will rise approximately 20.41 meters before it starts to fall back down. Now let's go to the free fall. In free fall, when an object is dropped, it falls due to gravity. The free fall equation is y is equals vi multiplied to t plus 1/2 multiplied to g multiplied to t squared. This is where y is the displacement and how far it falls, g is the gravity, which is 9.8 meters per second squared. So now I'm gonna give you an example. An object is dropped from a height of 45 meters. How long will it take to hit the ground? Let's assume that acceleration due to gravity is 9.8 meters per second. In this solution, using free fall, the equation is S is equals to ut plus 1/2 gt squared, where S 45 meters is the displacement, u 0 meters per second is the initial velocity, and g is the 9.8 meters per second. And this equation simplifies to 45 is equals to 0 plus 1/2 9.8 t squared. And this gives us 45 is equals to 4.9 t squared. And now let us solve the t squared. T squared is equals to 45 over 4.9, which is resulting to 9.18. Now let us take the square root. T is equals 3.03 seconds. Thus, it will take approximately 3.03 seconds for the object to hit the ground. Now, let's talk about projectile motion. This happens when an object is thrown or launched into the air. It moves both horizontally and vertically at the same time. And now we break it into two parts, which is the horizontal motion and the vertical motion. In horizontal motion, the object moves at a constant velocity, meaning there is no horizontal acceleration. The formula for this one is Vx is equals to Vi times cosine, while the vertical motion is here, the gravity acts on the object, causing it to accelerate downwards. The formula for this one is Vy is equals to Vi sine theta minus g times t. Now, for our example, a projectile is launched from the ground at an angle of 30 degrees above the horizontal with an initial speed of 20 meters per second. How far horizontally does the projectile land? For our solution, we have number 1. Determine the horizontal and vertical components of the initial velocity. The horizontal component Vx is given by Vx is equals V times cosine theta equals 20 times cosine 30 degrees equals to 20 times square root of 3 over 2 is equals to 17.32 meters per second. The vertical component Vy is equals to V times sine theta is equals to 20 times sine 30 degrees is equals to 20 times 1/2 equals to 10 meters per second. Number 2. Calculate the time of flight. The time to reach the maximum height can be found using the formula T is equals to Vy over G is equals to 10 over 9.8 and equals to 1.02 seconds. The total time of flight, which is up and down, is T is equals to 2T equals 2 times 1.02 equals 2.04 seconds. Number 3. Calculate the horizontal distance traveled. The horizontal distance traveled is D is equals to Vx times T is equals to 17.32 times 2.04 resulting to 35.34 meters. So now the answer is the projectile will land approximately 35.34 meters horizontally from the launch point.